So now we're going to begin our discussion about Java monitor objects. And as usual, I'll start off by giving you an overview of what monitor objects are and explain how Java provides built-in versions of monitor objects that are used to ensure mutual exclusion and coordination between multiple threads running in a process. And you'll see this diagram quite a bit. It's the diagram I use to show visually how monitor objects behave. As always, I'll also give you a human known use of monitors as well, which is kind of a fun way of seeing the big picture view. So what is a monitor? Well, a monitor is a synchronization mechanism that was designed back in the early 70s. If you take a look at the link at the bottom of the page, you'll see one of the first papers by a guy named Per Brinch Hansen, who talked about the concept of monitors and how it could be used in order to be able to implement a synchronization mechanism. Here are a couple other things from that time frame. The Sydney Opera House was built, and the Elton John song Crocodile Rock was #1 on the Billboard charts, which is pretty funny. A monitor provides 3 capabilities to concurrent programs. First thing it does is it ensures that only one thread at a time has mutually exclusive access to a critical section. And we've talked about what critical sections are before. Critical sections, of course, are regions of code where you are going to be accessing shared mutable state, and you want to make sure there's only one thread at a time in there, either reading or writing to that shared mutable state in order to prevent race conditions. The threads that are running in a monitor can block, awaiting certain conditions or a certain condition to become true so that they can proceed. And a thread can also notify one or more other threads that conditions they're waiting on have been met. So those are really the 3 things you can do. You can ensure mutual exclusion. You can put yourself to sleep and kind of park, waiting for things to become more to your liking, for conditions to become to your liking. And you can signal other threads or a thread to wake up and see if they can make forward progress. All objects in Java, at least all traditional Java objects, can be used as built-in monitor objects. And again, these support 2 different types of synchronization, which are commonly used together, although you can use one of them by itself in a perfectly fine way. So the first type of synchronization mechanism that's provided by a built-in monitor object is mutual exclusion, which allows concurrent access and updates to share data without incurring the hazard of race conditions. And this is done, as we'll see, through the Java synchronized keyword. Every Java object has a single so-called intrinsic lock that's associated with it. So whenever you make a new object for a class that is going to extend either directly or indirectly the java.lang.object superclass, then you bring along with it this concept of an intrinsic lock. And this intrinsic lock is used to basically provide something called an entrance queue, which, as the name suggests, will be a queue of threads that are trying to enter the critical section. And of course, only one of those things can come in at a time. And the way that this all works under the hood is that the Java execution environment, be it the Java virtual machine or the Android runtime or whatnot, supports mutual exclusion using this entrance queue, as well as synchronized methods and/or statements. The second capability that a monitor object supports in Java is coordination. And this ensures that computations run properly. And by that, I mean in the right order, at the right time, under the right conditions, and so on and so forth. Every Java object has an intrinsic condition, although it's not really called that, but that's what I call it to match the intrinsic lock. It has an intrinsic condition associated with it. And Java's execution environment, again, a virtual machine or the Android runtime, supports coordination by using a wait queue and a couple of different notification mechanisms. So those are the basic synchronization capabilities that are built in to every Java object, whether you know it or not, and whether you use it or not. These different mechanisms implement a variant of something called the monitor object pattern. And this pattern appears in the Pattern-Oriented Software Architecture Volume 2 book, which I wrote about 20 years ago. And you can also read about this if you take a look at the link at the bottom of the page. The intent of this pattern is to ensure that only one method runs within an object at a time. The implication, of course, being that there's concurrent threads that are calling other methods or the same method more than once. And this pattern also allows object methods to cooperatively schedule their execution sequences. So they can allow one thread to proceed and one thread to block and other threads to block and so on and so forth. And as we'll see, this pattern appears all over the place in concurrent Java programs. As always, I try to give a human known use of monitors just to make things a bit more intuitive. And one example of a human known use of a monitor would be an operating room in a hospital. And the basic idea here is that you will come and check in at some kind of check-in desk to let the doctors and nurses know that you're there. And so you go into the check-in area. And then basically the way it's going to work, especially in a COVID world, you can only have one patient at a time in the operating room. So that's the critical section. Critical now here being sort of a pun because you're maybe doing critical surgery. But the idea here is that you only have one person, one patient at a time in there. Of course, you could have multiple doctors or nurses. We don't count those. And at some point, let's say they do an operation on you and they have to wait for you to heal a little bit, or maybe they need to wait to, for some equipment to show up or some medicine to show up. And when they're not operating on you, they will go ahead and park you in an adjacent waiting room. And that allows another patient to come in and conceivably they, re-sanitize the operating room and start operating on you again. But there's only ever one patient in the operating room. And when someone can't make forward progress, they park you off in a waiting room. And then when you're done, or when they're done with the current patient, they'll park the current patient off in another waiting room, bring you back in, and so on and so forth. So there's only ever one person, one patient in the operating room at a time. It's not the world's most perfect analogy, but hopefully you get the point. So that's the end of the overview of Java monitor objects. Of course, we're going to look at all these mechanisms, mutual exclusion and coordination, in quite a bit more detail. And we'll take a look at a whole bunch of examples that illustrate how to program using Java built-in monitor objects.